Welcome back everyone to another video, and I know this is quite surprising for me to make back-to-back content like this, but wait, hold up, because if you just move out of your house and stroll around for a bit, you may find Ed Sheeran hanging on the sides of the auto, or maybe just on the backseat of Arjit Singh's scooter singing. So this is not as surprising as me making a content on the next day, and I think the world's getting smaller and smaller day by day. But the main question is, did I meet Ed Sheeran? Hell nah. Previously, we had completed about operators in Python. Now, the only portion that was left was bitwise operators. So we'll be completing this today. So what are bitwise operators? These are a special set of operators in Python whose main aim is to perform bitwise calculations. Okay, we have many kind of operators in this bitwise operators, this category. They are the bitwise AND, the bitwise OR, the bitwise NOT, bitwise XOR, bitwise right shift, sorry, this will be right shift, and this one is the left shift. Okay, you need to know the syntax and how they work. Okay, so first, and it's, suppose you have a variable called x, another variable called y, you just need to put the ampersand over here. This is the bitwise AND. Similarly, the OR, and for the NOT, it just take one value. So just like this is called the tilde operator or the tilde character, and you just need to put the variable. The bitwise XOR takes two operators. Right shift, it takes only one operator. You just need to put like this. Similarly for the left shift, just like this. Okay, now how these operators work, I mean how they function, they're what you say as the mechanism. So for the ampersand, it is just like the AND operator which we have done in a previous lesson. It checks. Now this one only works for bitwise. Suppose, let's say you have a variable, let's say x equals to 7 and y equals to, let's say 400. So the binary is, for 0 it's 0 0 0 0, for 1 is 0 0 0 1, for 2 is 0 0 1 0, for 3 0 0 1 1, for 4 is 0 1 0 0. Okay, so now remember, this is in the 4-bit representation. In Python, there is a fixed length of representation called the 8-bit, and we need to perform all the operations in the 8-bit. Okay, so for 4, it should be 4 zeros in the first, then 0 1 0 0. Similarly for 7, it's 4-bit, then 0 1 1 1. Okay, now for AND, it checks whether, like in the logical AND, it checks if two conditions are true, then only the result will be true. For bitwise AND, it checks if these ones, like this, the zeros and ones, the what you say the bits, are ones or not. So suppose I have over here 0 0 0, 4 zeros over here, and then 0 1 1 1, 8, 0 0 0 0 0 1 0 0. Okay, now it will check this one over here 0, so 0 0 0 0. Similarly 0. Now here it is a 1, similarly it is a 1 over here, so it will give the answer as 1. Here it's a 1, but here it's a 0, so it will be a 0. Similarly a 0 over here as well. So what it does is, it is checking whether both the bits for 7 and for 4 is a 1 or not. If it's not a 1 for both of them, then it will return as 0. Okay, the binary representation for this result is 4. So you will be getting the result for x and y as 4. Similarly, for OR, what this does is, I'm not giving the like the 4 bits over here. I'm just writing only the 4 bit, not the 8 bit, just for simplicity. Now it will check. We have 2 zeros over here, so it will definitely be a 0. We have 2 ones over here, so a 1. We have 1 over here and 1 0, but since 1 is present, so it will be a 1. Similarly, a 1 over here. The result over here is 7. So x and y is 7. Now the NOT. Now I think before I start with NOT, it's better to start with XOR, but still I'm going with NOT. So it just takes one operator. If you have watched my previous lecture, it just takes one operator. So if I have to give in the form of a truth table, let's say x, and this is the result 0 1, and result means x over here, it will give 1 0. This is how the not operator works. Okay, now suppose I have x, let's say I have x as maybe it is as 5. It will be easier for me. Now the binary representation in 8-bit, that is 0 0 0 0 0, then we have 1 0 1. Now what the NOT operator does is, it will change all the zeros to 1 and change all the 1 to 0. So will be having 1 1 1 1, 4 ones, then another 1, then 0, then 1, then 0. This is the binary representation of a result, but we don't know what the result actually is, and it's simply not possible to convert it just like this, like from the binary to the actual result. So if you have the result, like if you can do it like Python does this, so you also can do this, but it will be a bit more hectic, and that's not the point of this lecture. So we'll be using Python and get the result. It will be -6. I know the result. So how it is -6, our main focus is to prove it. So -6 means we first have to know the binary representation of 6. That is 0 0 0 0, then 0 1 1 0. This is the 8-bit binary representation of 6. Okay, now we need to find the 2's complement. Now if you have learned this, you will be learning this in computer science. If you've taken up in like I have learned this in my 12s or maybe in the 11th, I forgot, but you will be learning this or in your college maybe. Anyways, the main thing is, what is a 2's complement? 2's complement means 1's complement plus 1. Now what is 1's complement? 1's complement means you need to convert all of this to its what you say, the opposite one. Like if you have a 0, you need to convert it to 1. If you have a 1, you need to convert into a 0. So the 1's complement for this will be 1 1 1 1. Then for this is 1 0 0 1. Okay, now you need to add this 1 over here. So how will be adding this? 1 plus 1 is 2. Wrong. 1 plus 1 is 0. You need to know the binary addition rule. In binary addition, if you have a 1 and a 0, it's 1. If you have a 0 and a 1, it's also 1. But if you have a 0 plus 0, it's also 0. But if you have a 1 plus 1, it becomes a 0 with a carry equals to 1. Also, if you have a 1 plus 1 plus 1, it becomes 1 with a carry of 1. You need to remember this. So we have a 1 plus 1 it becomes 0, and you need to put the carry over here, just like you did in arithmetic mathematics. Like in your lower sections, you need to, like when you add with 17 and 18, you need to add this, you had a 1 over here, and then you need to add all of this and get 3, just like that. So we'll be doing the same thing over here. We added 1 plus 1, we got 0 with a carry of 1 over here. We'll be adding 1 plus 0, it became 1. Now 0, 1, 1, 1, 1, 1. And this 1 over here, this one over here is the minus representation. Okay, so what the 2's complement, like what we did is, we found the negative representation of 6. That's the main focus of 2's complement. And as you can see over here, the final result 1 1 1 1 and then 1 0 1 0 is the value of minus 6, and this one over here is the signed bit. Okay, it carries the sign of the number. Okay, so the result of x equals to 5, the bitwise NOT of x is minus 6. Okay, next we have the XOR. Now for XOR, you need to know one thing. Suppose you have x and y, and if you're doing XOR, like if you are doing in the form of a truth table, then you need to know one thing, that for odd number of ones, it will always be a 1. Like you have 1 over here, like 1 1. Similarly, 1 1 and 1 0, so it will be a 1. But over here you have 2 1s, so it will be a 0. Similarly, you have no 1, which means 0 number of 1s, so this will also be a 0. Okay, so we'll be taking the same example as x equals to 7 and y equal to 4, 0 1 1 1, and over here 0 0 0, just like that, and the answer will be 1 1 0 0. This is 3. So x or y is equals to 3. Next we have the right shift and the left shift. So it just takes one variable. So this is the right shift and this is the left shift. So let's just start with the left shift. Suppose the value of x is 10 and you want to like shift x to 2 binary places. Now what this means is, suppose we have 10 over here, so the binary representation of 10 is 1010, and if you want to shift to 2 places, what you need to do is you need to add 2 places over here, and this is the binary representation of, like when you shift the value of 10 by 2 places. So you need to find the value. For that, what you do is you need to find like this. Okay, then like this is a 4, and lastly you have like this. So the final value is 2 to the power 5 is 32 and 2 to the power 3 is 8, so the value is 40. Similarly, if you want to shift to the right, so 10, right, you have to use the binary representation, and if I want to shift it to the right by 2 places, you need to add 2 zeros in the front, then 1 0, and just remove this, just ignore it. Okay, so this is the binary representation of 2. How I know this? 0 to the power 0, sorry, 0 to the power 0 plus 0, sorry, 1 to the power 1 to the power 1 plus 0 in square, and like this, to the power 1 is 2. This is the answer. So this is how you do it. It's quite easy, and if you just open up VS Code, I'll just be showing you. So this is the code over here, and like this is like over here, this is for the bitwise and the bitwise or, the bitwise not, then the XOR, the right and the left shift over here. So if I just run it, we will be getting over here all the values for and, for or, for not. This one is for the XOR, while this one's over here either right and left. Okay, so you can just write this code and we will be good to go. I know it's quite a theoretical approach what I've done right now, but I think it's also the best way to understand bitwise operators. So if you like this video, then hit the like button, and if you're new to my channel, hit the subscribe button and press the bell icon so you never miss an update, and do share it with your friends as well, and I'll be seeing you next time.